Book 1. Unit 1. The Biomedical Engineering Technologist. Exercise 5, page 5.
Lincoln Medical Center, Jobs Directory, Job Summary. BMET needed to maintain medical equipment at Lincoln Medical Center. He or she must be detail-oriented. Applicants must have basic skill set, such as calibrating equipment. We train employees on some specific hospital equipment. Essential responsibilities. Technologists will check and repair medical devices. These include EKG and EEG machines. The technologist will inspect medical equipment for wear and repair damages. Technologists also assess and install new equipment. Requirements. The technologist must have an associate's degree in biomedical technology.
Unit 2. Manual Devices. Exercise 5, page 7.
Medical technology, an evolution. There have been many improvements in medical technology. Mercury thermometers were exchanged for electronic instruments. The newer thermometer gives more precise readings of temperature. Dr. Robert Calvier has 30 years of experience. Dr. Calvier still prefers manual devices. He uses a manual microscope to observe samples. Mercury thermometers make many of my patients comfortable, he says. It's what they grew up with. Mechanical scales are widely used to measure weight. These scales are typically accurate. Stethoscopes are still used to listen to heartbeats. Manual sphygmomanometers give good readings of patient blood pressure. In some cases, electronic devices are more expensive, with more hassle.
Unit 3. Hospital Departments. Exercise 5, page 9. Anderson Hospital. Anderson Hospital's dedicated staff is here to serve you. Our first-class departments include Cardiology, investigates and treats all heart problems. Chair, Dr. Paul Sarton. Dermatology, cares for everything from warts to skin cancer. Chair, Dr. Jeff Schmidt. Emergency, treats patients in life-threatening condition. Chair, Dr. Douglas Green. Pediatrics, provides healthcare from birth to adulthood. Chair, Dr. Richard Collins. Obstetrics, cares for women through all stages of pregnancy. Chair, Dr. Susan Meeks. Orthopedics, provides bone and joint care. Chair, Dr. Catherine Newland. Pathology, tests samples for all departments. Chair, Dr. Laura Howard. Radiology, creates X-rays and CT scans for all departments. Chair, Dr. Thomas Locke. Surgery, performs everything from routine procedures to organ transplants. Chair, Dr. Rachel Silver. Pharmacy, provides medicine and prescriptions 7 days a week. Chair, Dr. Charles Thiel. Unit 4. Hospital Staff. Exercise 5, page 11.
Anderson Hospital, Staff Directory, First floor. Dr. Paul Sarton, Cardiologist, Surgeon, Office 100. C for Heart Disease, Heart Surgery. Dr. Lydia Greenwich, Anesthesiologist, Office 101. C for Surgery, Pain Relief, and Preparation. Dr. Richard Collins, Chief Pediatrician, Office 102. C for Children's Health. Dr. Ann Harold, Obstetrician, Office 103. C for Labor, Pregnancy. Dr. Thomas Locke, Chief Radiologist, Office 104. C for X-rays, CT scans. Carol Howard, Lab technician. See for test results. Second floor. Dr. Rowan McNeil, general practitioner. Office 202. See for general medicine. Carol Simmons, NP, head nurse. Office 203. See for nursing schedules. Dr. Charles Teal, pharmacist. Office 204. See for prescriptions.
Unit 5. Safety 1. Exercise 5, page 13. Safety first. Safety is everyone's responsibility. When working with hazardous, toxic, or flammable materials, always wear personal safety equipment. This includes goggles and gloves. Use respirators and coveralls as needed. Know where the eye wash station is. Immediately use it if chemicals come in contact with the eyes. Rinse eyes until medical professionals arrive. Store all chemicals in appropriate safety cans. Inspect often to make sure they're in good condition. Label the cans correctly. Make sure electrical devices are unplugged. Always wear electrical PPE. Never work on electronics without this insulated material. Unit 6. Safety 2. Exercise 5, page 15.
The biotechnical workplace. There are many potential dangers in this position. When working with medical equipment, problems can occur. Chemical dangers include spills and burns. Chemicals with a high toxicity can cause illness or death. Machinery should be maneuvered with caution. Mechanical failings might cause severe physical injuries. Electrical dangers can cause severe trauma. An exposed wire on equipment can cause shock. This is why technicians use an electrical analyzer. The analyzer determines whether or not a wire is hot. When hot, a wire should not be touched. Technicians wear PPE to guard themselves from potential injury. Gloves, boots, goggles, and other equipment serve as protection. In addition, practicing fire safety can prevent serious injuries.
Unit 7. Numbers and Basic Math. Exercise 5, page 17.
How do they say it? Symbol, is. Interpretation, is equals comes to. Examples, 0.25 equals 1/4. Symbol, and. Interpretation, and plus add. Examples, A plus B equals C. Symbol, minus. Interpretation, minus less subtract. Examples, A minus B is C. Symbol, times. Interpretation, times multiplied by. Examples, A times B comes to C. Symbol, over. Interpretation, over divided by. Examples, A divided by B equals C. A over B is C. Symbol, 1,500. Interpretation, 1,500 or 1,500. Examples, the beaker has 1,500 cubic centimeters of water in it.
Unit 8. Analyzing Quantities. Exercise 5, page 19. Chapter 2. Talking about quantities. Sometimes there's more than one way to talk about the same number. Let's take the number 0.5. We can give it many different names. We can call it 0.5. This is a decimal number. If we call it 1/2, it's a fraction. We can also say 1 out of 2 or 50%. They all mean the same thing. It works with mixed numbers too. When we reduce an improper fraction, we end up with a whole number plus a fraction. For example, 5 over 4 reduces to 1 and 1/4. We can further convert this number and end up with 1.25. Unit 9. Measurements. Exercise 5, page 21.
Lab Conversion Manual. Often we need to convert between metric and imperial systems. The following chart should assist you with these conversions. Weight. 1 gram equals 0.035 ounces. 1 ounce equals 28.35 grams. Volume. 1 milliliter equals 0.034 fluid ounces. 1 fluid ounce equals 28.41 milliliters. Distance. 1 centimeter equals 0.39 inches. 1 inch equals 2.54 centimeters. Temperature. To convert from Celsius to Fahrenheit, follow this formula. Degrees Celsius times 9 over 5 plus 32. To convert from Fahrenheit to Celsius, follow this formula. Degrees Fahrenheit minus 32 times 5 over 9. Thus, 0 degrees Celsius equals 32 degrees.
Unit 10. Common parts. Exercise 5, page 23.
June 10th. Desk of Dr. Angela Peterson. Number 1. A loose knob on the anesthetic gas monitor should be checked. Number 2. Compartments of the gas monitor shelf need to be resized. Number 3. Notches on the dial on the manual scale are incorrect. The device needs to be calibrated. Number 4. The cuff for the sphygmomanometer doesn't inflate properly. Number 5. A switch on the control board is stuck. Number 6. The new recorder modules need to be installed. Number 7. The system printout needs to be checked against past readings. Number 8. A telephone cable is fraying. This cable needs to be replaced. Number 9. The hose leaks. It needs to be checked for damage. Number 10. The EKG machine's AC power cord doesn't reach the outlet. The machine will be moved.
Unit 11. Describing Problems 1. Exercise 5, page 25.
Departmental Assessment, August the 27th. Problem 1. The thermometer sensor is broken. Its screws are loose. It turns on but no longer signals temperature changes. Problem 2. The electronic scale model number FTY789J5 in the lab is malfunctioning. It keeps giving incorrect readings. This happens when we weigh patients. We compared the reading to the other scale in the lab. The other scale is correct. Problem 3. We attempted to run a program on the lab computer. The program consistently fails. The program gets stuck before completing the process. The computer has to be turned off. When rebooted, the monitor is slow to turn on.
Unit 12. Describing Problems 2. Exercise 5, page 27.
Anderson Hospital. Employee memo. Dan, we ran into a few problems last night. The radiology department called about their main electrical panel. They experienced a leak and it shorted out their system. I checked it out and water hit some frayed wires. One wire completely split. The surrounding wall is very warped. We should check for water damage in nearby areas too. There must be a hole in a pipe somewhere. Second, we have 3 IV pumps. One has a crack in the frame. We'll have to replace it. The pump on the second blew. I think it's probably from wear and tear. Please see if you can find out what happened. The third IV pump just has a clog in the line. Thanks, Sheila.
Unit 13. Monitoring Equipment. Exercise 5, page 29. Report. From Aaron Jackson. ID 4582224. I checked the monitoring equipment in laboratory number 2. The physiological monitoring system seemed to function well. I took readings of heart rate that were accurate. The ECG waveform gave similar readings. The central station monitor did not reflect these readings. This monitor should be sent to the manufacturer. The multi-parameter monitoring system had issues with accuracy. Some of the vital signs seemed normal. However, other vital signs looked inaccurate. Both blood pressure and blood oxygen content seemed high. Temperature readings were low, but understandable for that patient. Further tests on this system are necessary. I am unsure if the respiratory rate is accurate. Unit 14. Preventing Infections. Exercise 5, page 31.
From Sandra Green, Hospital Director. To all staff. Subject: Preventing Infections. Attention hospital staff. The flu season is approaching. It's important to maintain strict hygiene standards. Contagious new viruses and strains of bacteria cause problems in hospitals every year. I do not want that happening here. Regularly wash your hands with antimicrobial soap. Clean surfaces with disinfectant according to the maintenance schedule. Dispose of biohazards carefully and correctly. Should drug-resistant flu strains appear, we must quarantine all infected persons. Do not enter quarantine areas without a face mask. We want to avoid transmitting infections any further. We want the patients on antibiotics, not the staff. Thank you for your help. Sandra Green, Hospital Director.
Unit 15. Education. Exercise 5, page 33.
Therial Smith Community College. BMETs have a passion for both chemistry and computer science. In our program, you will get all of the necessary training to follow your dream and get a BMD. For BMET certification, you can study for an associate's degree. This degree will be in biomedical engineering technology. We offer a variety of specializations. If you're just interested in the study of electricity, you can get a CET. Those interested in other aspects can get a CBET. The CET does not grant BMD accreditation. CLES certification is the general certification in the study of all laboratory equipment. CNES certification focuses on nephrology equipment. CRES certification focuses on radiology equipment.
Book 2. Unit 1. SI Units. Exercise 5, page 5. Learn your SI units. In the SI, a few base units make up many derived units. A kilogram is a base unit of mass, and a meter is a base unit of length. These and a few other units are used to calculate many properties. For example, mole per cubic meter is a derived unit of substance concentration. Moles and meters are required to calculate it. The formula for this derived unit is mole per meter cubed. Here are some other common derived units. Name: degrees Celsius. Measurement: temperature. Base units: Kelvin, K. Formula: degrees Celsius equals Kelvin minus 273.15. Name: Pascal, PA. Measurement, pressure. Base units, kilograms, meters, seconds. Formula. Pascals equals kilograms divided by meters times seconds squared. Name, Newton. N. Measurement, force. Base units, kilograms, meters, seconds. Formula. Newtons equals kilograms times meters divided by seconds squared. Name, joule. J. Measurement, energy. Base units, kilograms, meters, seconds. Formula. Joules equals kilograms times meters squared divided by seconds. Unit 2. Sensory scopes. Exercise 5, page 7.
Memo. 2 BMETs. From Nick Banka. Date, September 21st. Subject, new scopes and other equipment. On Monday, our hospital is receiving new equipment. Everyone knows our bone densitometer broke, so we're now replacing it. We're also upgrading our electronic probe thermometers, endotracheal tubes, and obstetrics equipment. We will remove the old fetal monitors and fetal heart detectors today. Additionally, be aware of new scopes our hospital is receiving. For example, many of you are unfamiliar with laryngoscopes, a tool for examining patients' larynxes. Please meet with department heads to learn how these instruments work. Most of you are probably familiar with ophthalmoscopes and otoscopes. However, you should review instructions for the newer models. Unlike the current scopes, they come with slit lamps and tympanic thermometers. Please contact me with any questions. Remember, it is everyone's responsibility to learn about the new equipment. Nick Banka, COO.
Unit 3. Endoscopes. Exercise 5, page 9.
Using a MedPro. Endoscope. MedPro endoscopes are some of the most versatile and durable endoscopes available. For best use, consult this manual for operating both flexible and rigid models. Components. All MedPro endoscopes contain certain basic components. Each model should contain a rigid or flexible tube, a digital camera, a light source, a video monitor, an optical fiber system. Do not use your MedPro endoscope if any of these parts are missing. Consult MedPro for a replacement. How to use. Using the MedPro endoscope is different in every procedure. However, each operation should follow certain precautions. 1. Clean the operation site using an irrigation method. 2. Use a suction tool to fully remove site contaminants. 3. If necessary, use an insufflator or other instrument to administer anesthetics. 4. Safely insert the endoscope into the cleaned channel in the operation site. These directions are in place for your safety. If you have any questions, contact a MedPro representative at 906-555-0287.
Unit 4. IV pumps. Exercise 5, page 11.
Mark. The IV pump in this room isn't working. A patient noticed it yesterday. Luckily, she wasn't injured. You need to replace the pump before you shift today. The patient requires parenteral medication, and IV is the most direct route of administration. The pump seems to have broken roller clamps. Yesterday's patient felt nauseous, and when I checked the pump, the infusion rate was wrong. The pump administers a continuous drip when it should be intermittent. Be sure to find a replacement pump with micro drip and macro drip settings. Your patient will use both. The first setting is for administering medication, and the second delivers a normal saline solution. If I'm correct, there are new IV pumps on the third floor. We got them in yesterday. Ask for Nurse Jones, as she knows where to find them. I'll let her know you're coming up there today. Karen.
Unit 5. Imaging Equipment 1. Exercise 5, page 13. Office of Dr. Joseph Owens, MD. Imaging Services. Our office offers the newest advances in bioimaging technology. Below is a list of the imaging services we offer. X-ray services. X-ray machines use ionizing radiation to produce high-quality images. The two X-ray services we offer are traditional radiography, two-dimensional images of bones, tumors, obstructions, etc., CT, computed tomography scanning, three-dimensional images of organs, bones, and tissues. Ultrasound services. Ultrasound machines use high-frequency sound waves to produce images. We use the most advanced technology available, which reduces visual noise and improves contrast. The two ultrasound services we specialize in are obstetric ultrasounds, examining a fetus by applying ultrasound transmission gel and creating a fetal projection on a monitor. Doppler echocardiology, examining the heart, blood vessels, and blood flow using the Doppler effect. Endoscopy services. Endoscopy uses fiber optics to view the interior of the body. It works by feeding a camera tube through a cavity or surgical opening. Unit 6. Imaging Equipment 2. Exercise 5, page 15.
Chicago Medical Journal, Technological Advances in Bioimaging by Jeffrey Poring. Bioimaging technology is getting better every day. Digital photographs are increasing in pixels, and electron microscopy is helping us better understand cell biology. However, there are also more advanced bioimaging techniques. These help identify symptoms and other modalities and cure diseases. Many people who think of bioimaging think of confocal imaging. While this technique is important, its use of fluorophores is sometimes limiting. Therefore, many specialists prefer using MRIs. This technique produces images using cells' magnetic fields, and a similar technique called MRS can examine the brain. fMRIs are used for brain imaging as well. When MRIs cannot be used, PET imaging is sometimes more effective. This technique relies on radioactive molecules created by a cyclotron. After releasing these molecules into the body, a gamma camera reads them and produces images. Alternately, SPECT imaging is sometimes used instead of PET imaging.
Unit 7. Defibrillators. Exercise 5, page 17.
Frequently asked questions. MedPro defibrillator. What parts come with my MedPro defibrillator? Your MedPro defibrillator comes with a base unit and two non-polarized paddles. The base unit has a capacitor, a voltage multiplier, and a discharge relay installed. How should I store my MedPro defibrillator? We design MedPro defibrillators for storage on a standard-sized crash cart. Be sure to follow proper charge storage procedures to be prepared for medical emergencies. What are the basic controls on my MedPro defibrillator? Your MedPro defibrillator has a power switch and a control to boost the electrical charge. See page 12 for more detailed instructions. When should I use a defibrillator? People use defibrillators to treat cardiac dysrhythmias, ventricular fibrillations, and ventricular tachycardia. It is uncommon, however, to use a defibrillator for atrial fibrillations. What is the treatment mechanism of a defibrillator? Defibrillators send an electrical surge into a patient's body. This surge causes the heart to contract regularly again.
Unit 8. Circulatory System Equipment 1. Exercise 5, page 19. Equipment list. Name of item. Pulse oximeter. Checked in, out, and reason. Nursery checked out the oximeter as some newborns needed oxygen levels retested. Repaired, returned, non-applicable. Name of item. 2 syringes. Checked in, out, and reason. Anesthetics department checked out syringes needed for transcutaneous morphine administration. Repaired, returned, non-applicable. Name of item. CO2 analyzer. Checked in, out, and reason. Intensive care unit checked in the item as the patient no longer needs his breathing apparatus. Repaired, returned, returned. Name of item. Glucometer. Checked in, out, and reason. Warehouse staff checked in the item. It was being repaired for misreading blood glucose levels. Repaired, returned, repaired. Name of item. Doppler blood flow detector. Checked in, out, and reason. Cardiology department checked out the detector because some patients were experiencing blood flow issues. Repaired, returned, non-applicable. Name of item. Pressure transducer. Checked in, out, and reason. Coronary care unit checked out the transducer which they needed for telemetry, i.e. remote readings. Repaired, returned, non-applicable. Name of item. Non-invasive blood pressure monitor. Checked in, out, and reason. Cardiology department returned the item in exchange for the invasive monitor. Repaired, returned, returned. Name of item. Invasive blood pressure monitor. Checked in, out, and reason. Warehouse staff checked in the item. The catheter on the pressure monitor was being replaced. Repaired, returned, repaired. Name of item. POC analyzer. Checked in, out, and reason. General surgery department checked out analyzer to run preliminary blood tests. Repaired, returned, non-applicable. Unit 9. Circulatory System Equipment 2. Exercise 5, page 21.
Biomedical Equipment Technician, BMET Workshop. July 19, Kevorkian Center Conference Room. On July 19, the Kevorkian Center is hosting a workshop for aspiring BMETs. Do you know the difference between a manual and automatic tourniquet? Can you identify a drip chamber, fluid controller, and other parts of an IV system? This workshop answers all your BMET questions. Event schedule. 2 p.m. Understanding fluid warmers. Demonstration. This workshop includes a demonstration of blood warmers, including dry heat warmers and warm bath warmers. 3:30 p.m. Pumps, pistons, and other fluid movers. Interactive workshop. Workshop participants learn to attach, inflate, and/or use different fluid movers including PCA pumps, pressure infusers, peristaltic pumps, piston pumps, sequential compression devices. 5 p.m. Becoming a perfusionist. Speaking event. Mr. Jordan Burns talks about his responsibilities as a perfusionist. The event includes a demonstration of a heart-lung machine. Admission is $40. All participants receive a MedPro t-shirt and a blood pressure cuff sleeve.
Unit 10. Respiratory System Equipment 1. Exercise 5, page 23.
New Respirators, New Medical Workers by Brian Calton. Respiratory system support equipment is different today than years ago. Iron lungs and other negative pressure ventilators are now mostly obsolete, replaced by better technology. These new mechanical ventilation technologies require skilled workers to handle them. For example, many respirators today are positive pressure ventilators. These instruments use compressors, which pipe in compressed air to patients' lungs or tracheas. They do this using face masks, endotracheal tubes, or other devices. Are these devices more complicated than older technologies? In some cases, yes. However, they are mostly just different. While iron lungs required knowledge of bladders and bellows, today's technicians use local tanks and gas supplies. Medical workers now need to be trained in a newly specialized manner. Additionally, there are other situations when today's medics need special training. In a percutaneous tracheostomy, for example, a practitioner uses specially modified forceps. Someone performing a traditional tracheostomy would not need this knowledge.
Unit 11. Respiratory System Equipment 2. Exercise 5, page 25.
Settings and measurements. MedPro ventilators are capable of several different settings. Familiarize yourself with these options before using your ventilator. How it works. The ventilatory cycle. MedPro ventilators work by completing ventilatory cycles. A full cycle includes an inspiratory phase, inspiratory pause, expiratory phase, and expiratory pause. Types of readings. MedPro ventilators display current pressure settings, volume settings, and inspiratory pressure and I to E ratio. Users can adjust these settings as needed. Pressure settings. MedPro ventilators are capable of many different pressure settings. Users can control a ventilator's units: airway pressure, peak inspiratory pressure, CPAP, continuous positive airway pressure. Volume settings. Different patients require different air volume settings for ventilation. MedPro ventilators can adjust the following settings: tidal volume inspired, minute ventilation, tidal volume expired. Additionally, MedPro ventilators include a few special volume settings. These include HFOV, high frequency oscillation ventilation, IRV, inverse ratio ventilation, and SIMV, spontaneous intermittent mandatory ventilation.
Unit 12. Renal System Equipment. Exercise 5, page 27.
Chapter 12. Renal System Equipment. The renal system is one of the most important systems in the body. It removes waste products from the bloodstream and involves the kidneys, bladder, and other organs. One treatment for the renal system is hemodialysis. This procedure purifies blood for malfunctioning kidneys. To perform hemodialysis, doctors use several types of equipment. These items may include a water purification system for cleansing water supplies, a tunneled or non-tunneled catheter for assessing the bloodstream, a dialyzer for cleansing the blood, a peristaltic pump to redeliver blood to the bloodstream, surgical instruments for constructing an AV fistula. These instruments help remove, purify, and return blood to the body. However, not all of these items are necessary for hemodialysis. A doctor must examine a procedure's access point and other factors to determine necessary equipment. In more complicated circumstances, a procedure may require additional items.
Unit 13. Anesthesia Equipment. Exercise 5, page 29. Anesthetic Machine Maintenance Checklist. Complete this checklist before using the anesthetic machine. Gas, oxygen pipes, and valves. Ensure all pipes are clean and free of leaks. Test valves in on and off positions to ensure proper delivery of anesthetic agents. Gas tanks and containers. Ensure all gas tanks are clean and free of leaks. Check for cracked seals that may allow gases to escape during anesthesia procedure. Vaporizer setup. Check volume gauges to ensure the vaporizer is working at full capacity. Also test gas monitor for accuracy. Humidifier. Ensure humidifier is clean and free of standing moisture. Test system in on and off positions and check for heated air delivery. Note: this step is extremely important for preventing patient hypothermia. Breathing circuit. Ensure breathing circuit is properly recirculating air. Replace soda lime in canister to ensure it properly absorbs carbon dioxide. Backup battery power. Ensure backup battery is charged and ready for use. Unit 14. Infant Care Equipment. Exercise 5, page 31.
Maintenance report. Date, December 16th. This year, equipment repairs and replacements were above average. The obstetrics department required many new supplies during its recent renovations. BMETs repaired the following items in the past 12 months. 2 photometers, taking inaccurate measurements. 1 bilirubin light, producing light outside the ultraviolet range. 2 incubators, with damage to their gasket-sealed hatches. Additionally, BMETs replaced the following items: 8 APGAR timers, 6 infant resuscitators. All staff should be careful with the new equipment. Overhead lights and other supplies for bilirubin therapy are expensive and difficult to replace. If this equipment breaks again, our hospital will have too many newborns to treat. If possible, we should consider cheaper treatments for infants with excess bilirubin. Fiber optic blankets are one possible option. Besides being less costly, these are also easier to fix than standard lights. Please contact your supervisors with any possible cost-saving measures. John Richter, Head BMET.
Unit 15. Surgical Tools. Exercise 5, page 33.
Chapter 6. Electrosurgical Tools. Electrosurgery machines are the basic tools in electrosurgical procedures. Their features vary, but all include active electrodes or sources of electrical current. They also include sinks that remove electricity from the patient. Additionally, all electrosurgery machines have a few basic settings. They can cut or coagulate a surgical site. Machines also include a blend setting, which is in between cut and coagulate. However, electrosurgical machines perform different procedures. The type of procedure affects the features of each machine. Monopolar operations use grounding electrodes and foot switches, for instance, while bipolar operations do not. A grounding electrode is the sink that removes electrical current from a patient. In a bipolar operation, electrosurgical machines do not include this electrode. They instead use forceps that cut and cauterize by transferring electricity between 2 jaws. One jaw is an electrical source and the other is a sink. These tools give surgeons many options for performing procedures.
Book 3. Unit 1. Computers. Exercise 5, page 5. Memo. Workstation setup. To Biomedical Equipment Technician Department. From Technology Manager. It has come to our attention that we need an additional mobile computer station on the nursing floors. Because of the current shortage of computers, nurses are often unable to admit patients quickly. The shortage also affects the ability to access patient records and patient history when needed. Therefore, it's very important that we set up a new mobile computer station right away. Could you please take care of this by the end of the day today? The Information Technology Storage area holds all the equipment you need. There are no extra laptops available, so use a desktop instead. Position a monitor on the top of a wheeled workstation cart. Make sure it is at a comfortable viewing height. Then, place a keyboard and a mouse on a pull-out drawer so that they are out of the way unless needed. Connect the components and properly set up the computer on the server. Before delivering the workstation to the main nursing floor, briefly test it to make sure that it functions properly. Also, make sure the workstation is comfortable and easy to use. Let me know if you have any questions. You can reach me on my smartphone at any time today at 777-555-3399. Unit 2. Networks. Exercise 5, page 7.
From IT manager at qualityhealthcare.com to BMET associate at qualityhealthcare.com. Subject: networking help. Hi, Brian. Do you have some time over the next week or two to help us here in the IT department? Because the company has brought on a lot of new staff members recently, we are swamped with work. Many of the new employees still do not have access to the facility's LAN. If you could configure their computers so that they can access the network, that would be a big help. You can set up these connections easily with Cat5 cables. Most of the new employees still need usernames and passwords so that they can log in. In addition, we need to set up the appropriate permissions for data sharing within their departments. It's important that we get these employees set up on the network as soon as possible. We also need some help setting up a WLAN. This would allow employees to connect to the intranet via Wi-Fi technology from certain areas of the building. Employees could then connect to the network as guests on their laptops. Please let me know if you have any time to help us with these tasks. I need to concentrate on troubleshooting the router and network switch, so I would very much appreciate your assistance. Thanks, Mary White, IT Department Manager.
Unit 3. Batteries. Exercise 5, page 9.
Hospital Employee Handbook, number 5, Batteries. All batteries should be stored in the designated battery storage area. While most of them have long shelf lives, please make sure to use the older batteries in storage first. Additionally, make sure you follow your department's battery testing procedure. Regular testing allows us to ensure that equipment works properly. Before placing a new replacement battery in a device, test it with a battery analyzer to make sure it holds the proper charge. Many of our batteries are non-rechargeable. Place these batteries in the designated battery waste bins for disposal when they no longer work. Personnel will sort the batteries and recycle them if possible. However, some batteries, such as the Li-ion batteries used in many portable medical devices, are rechargeable. Before disposing of a battery, make sure it is not a rechargeable type. Always make sure to dispose of batteries properly. Many batteries contain mercury, a toxic substance. Individuals exposed to higher amounts of this element will experience negative health effects. While the mercury content in most alkaline batteries has decreased, we still use some batteries containing higher levels of mercury. Therefore, it is important to take special precautions during the storage and disposal of these batteries.
Unit 4. Technology Management. Exercise 5, page 11. January 16th. Hello, Mary. I just did an evaluation of our current technology. I found a few issues that I would like to bring to your attention. Our current incoming testing software for new employees refers to outdated technology that is no longer in use. Therefore, updating the staff education resources should be high up on our list of things to do. I think that the acquisition of new training software would be a good investment. Once purchased, we can perform the installation of the software in less than a week. In addition, we have a significant amount of broken or old equipment. We can fix some of it relatively inexpensively. However, we should decommission some of the older machines and replace them with newer versions. I recommend performing a life cycle cost analysis of potential new purchases to help ensure that we get the most from our acquisitions budget. Let me know what you think of these recommendations. I'd be glad to provide you with a written proposal where I detail the costs and benefits of potential plans of action. Whether it's fixing old equipment or obtaining equipment that utilizes newer technology, I'm confident we can find a good solution. Sincerely, Peter, Biomedical Equipment Technician. Unit 5. Physiotherapy Equipment. Exercise 5, page 13.
Repair request sheet. We are experiencing problems with the following devices used in the physiotherapy department. 1. CPM device. There is a problem with the range of motion of one of the CPM, continuous passive motion devices. While it is able to extend, the degree to which it flexes the affected body part is limited. 2. Whirlpool bath. We notice that the timer on this device is broken, requiring staff to carefully watch the clock instead. This makes it more difficult to ensure that patients remain in the whirlpool bath for the appropriate amount of time. 3. Wax bath. Because the temperature adjuster on this device does not work properly, we are unable to easily set the temperature of the wax. We have had to stop using the wax bath until repairs can be made. 4. Hot pack heater. Since the lid of the hot pack heater does not close properly, heated air escapes. This makes it more difficult to keep hot packs ready at the appropriate temperature. 5. Sequential compression device. There is a leak in one of the valves of this device. As a result, it does not apply enough pressure to the affected area of the patient's body.
Unit 6. Feeding pumps. Exercise 5, page 15.
Feeding pump manual. Introduction. In some cases, a patient is unable to swallow or consume food by mouth. This may be because the patient is unconscious or has problems with their swallowing mechanism. He or she may be on a ventilator or another type of device that interferes with eating normally. For whatever reason, the patient is incapacitated. It is vitally important that he or she continues to receive proper nutrition. In instances where patients cannot pass food from the mouth to the throat, we can feed them via an enteral feeding pump. When we feed a patient enterally, we deliver feeding solution directly to a person's gastrointestinal tract through a tube. We attach this tube to the feeding pump at the pump head. The pump then generates pressure to deliver feeding solution to the patient in a controlled manner. The pressurized mechanism allows us to regulate and monitor the amount of feeding solution the patient receives. By changing the pressure settings, we can modify the flow rate of the feeding solution in accordance with the patient's particular nutritional needs. Unlike other types of biomedical equipment, feeding pumps generally do not require air in-line detectors. This is because minor instances of air bubbles in the stomach typically do not cause problems for the patient.
Unit 7. Electroconvulsive therapy devices. Exercise 5, page 17. Treatment of mental disorders. Chapter 17. Electroconvulsive therapy. We use electroconvulsive therapy, or ECT, to treat various mental health disorders, such as depression and schizophrenia. In order to perform this treatment, a medical professional first attaches electrodes to the patient's head. The operator then administers a series of controlled electric shocks, with the goal of helping improve the patient's mental health. ECT has long been controversial. In the past, electrical shocks during this type of treatment would cause the patient's muscles to contract, resulting in uncontrolled movement. Today, ECT is safer for the patient. After receiving anesthesia, the patient typically receives a muscle relaxant that keeps the body motionless. If a cuff is placed on the patient's ankle, the doctor is able to monitor twitches of the foot during the procedure. A motion-sensing device will further help the doctor monitor the patient during treatment. This device, as well as ECG and EEG indicators, help ensure that the patient is safe. Too much electricity can be damaging to the patient. Therefore, it is very important to make sure that the ECT device functions properly. Today, doctors frequently prefer a brief pulse current. Rather than a continuous current, the ECT machine applies current in brief pulses. Unit 8. Testers 1. Exercise 5, page 19.
Biomedical testing professionals. Testing device catalog. We offer an excellent selection of testing devices for biomedical equipment. All of our devices are fully calibrated to provide the utmost in accuracy, and we guarantee your satisfaction. Digital multimeter. Use this device to measure several electrical qualities, such as current, voltage, and resistance. Receive accurate, easy-to-read numerical results on the digital screen. Oscilloscope. Analyze changes in electrical activity over time with this device that displays graphs on a computerized monitor. Tachometer. This device accurately measures the speed at which an object is rotating. It is especially useful for testing the spinning speed of centrifuges in biomedical laboratories. Oxygen analyzer. Use this product to obtain data on the oxygen content in a specific location. Our customers find this device particularly useful when analyzing devices such as ventilators and infant incubators. Manometer. With a highly accurate capacity for measurement, this device measures pressure and suction. It is frequently used to test devices such as non-invasive blood pressure units and ventilators. Sound level meter. This device measures sound intensity in a given location and is an important equipment testing tool. ESU analyzer. Use this device to perform performance assurance, PA tests, of electrosurgery units. It analyzes a variety of important factors, including power output and RF leakage.
Unit 9. Testers 2. Exercise 5, page 21. Introduction to Biomedical Equipment. Chapter 10. Testing Devices. In order to make sure equipment is functioning properly, we use a tester. These testers can serve as calibrators that help standardize a machine's measurements. For example, some devices deliver fluids to a patient's body in a controlled manner. In order to make sure that these devices perform consistently, we use an infusion device analyzer. Other devices, called ventilators, push air in and out of a patient's lungs. We use a ventilator analyzer to evaluate the performance of these devices. We also use a gas flow analyzer frequently. Other times, we use physiological simulators to recreate the functioning of part of the body for analysis purposes. An NIBP analyzer, a tester that analyzes non-invasive blood pressure measuring devices, can mimic the condition of arrhythmia. In this way, a BMET can observe how the machine would function with a patient with an irregular heartbeat. Another example is a test lung, which simulates the functioning of the human lung and tests respiratory devices. Other important testing devices include an incubator analyzer, which evaluates qualities such as temperature, airflow, and humidity. An SpO2 analyzer helps ensure that medical devices measure the blood oxygen saturation levels of a patient properly. Likewise, an ultrasound analyzer evaluates the performance of ultrasound imaging machines. Unit 10. Tools and Accessories 1. Exercise 5, page 23.
Job list for biomedical equipment technician. Please complete the following biomedical equipment repair tasks by the end of the week if possible. 1. Repair ventilator 8A and ensure that the wiring matches the user manual specifications. You will need pliers to open the control panel and cutters for trimming wire. A hammer may also come in handy for manipulating metal parts of the device. The incubator uses Allen screws, so bring a screwdriver with a hexagonal-shaped tip. 2. Identify and correct the problem with heart monitor number 447. While most of the machine uses slotted screws, it also uses a couple of other screw types. You will probably need Phillips and Allen screwdrivers in addition to a slotted screwdriver. 3. Fix the incubator analyzer. I'm not sure what size the bolts on the device are, so bring a socket wrench and a socket set. An adjustable wrench and a spanner may also be helpful. 4. Repair the broken components of the Whirlpool bath. This device uses torque screws, so make sure you bring a screwdriver with a star-shaped tip. Thank you for your attention to these matters. Please let me know if you have any questions about these tasks. Sincerely, Joe Thomas, Operations Manager.
Unit 11. Tools and Accessories 2. Exercise 5, page 25.
From bmet@healthsolutionscenter.com to Operations Manager at healthsolutionscenter.com. Subject: Request for additional or replacement tools. Hello, I'd like to request some tools to help me perform my job duties as a biomedical equipment repair technician. For example, an integrated circuit removal tool will help me remove integrated circuits from a circuit board with precision. Chip contact extenders would be a big help as well. When I measure very small spaces within biomedical equipment components, I like to use a micrometer caliper to get accurate measurements. The department's current micrometer caliper is broken, making the task of getting such measurements much more difficult. In order to view samples under low magnification, I'd also like a stereo microscope. Since regular cleaning supplies can't properly clean the mechanical and electrical components of biomedical equipment, I use contact cleaner instead. Could you order some more of this product, as well as some cleaning solvents? I'd also like to request more spray lubricant, adhesive, and sealant. Previously, I've had great success covering wires with heat shrink tubing. I'm running low on this material and would like to order more before I run out. Finally, I would appreciate a new box cutter and tape measure. I know this is a lot to request at one time, but these materials are important to my work. I appreciate your consideration of these requests. Thank you, Mary Jones, BMET.
Unit 12. Power Tools. Exercise 5, page 27. Tool Professionals Incorporated, manufacturer of quality tools for over 50 years. With the huge selection of power tools available, purchasing a new tool can seem overwhelming. When you purchase a tool from us, you can feel confident in your purchase. We have manufactured quality tools for over 50 years and design our tools to be high quality, user-friendly, and efficient. Our extensive product selection includes a wide variety of drills. Whether you need a cordless drill, a drill press, or a hammer drill, we have a product for you. We test our drills and drill bits extensively to ensure that they meet our high-performance standards. We also offer many types of saws, including both circular saws and reciprocating saws. If you are unsure which type of saw you need, one of our product experts will be glad to help you out. Another challenge is to create a smooth, finished look for your creation. One of our sanders can help you accomplish this. Another helpful product is a bench grinder. Use one of these for sharpening tools or for treating metal surfaces. We are confident that our products would be a great addition to your workshop. Give us a call today to discuss your options with a customer service representative. Unit 13. Soldering. Exercise 5, page 29.
Model 1400. Soldering Kit. This kit provides the materials you need for a basic soldering station. When selecting a location to use this kit, keep in mind that it requires access to a power supply. Additionally, either set up this kit in a well-ventilated area or use a smoke removal system to help keep the air clean. Excessive buildup of smoke and fumes while working is bad for your health. The soldering tip has one heat setting and attaches to the handle. Since the tip gets very hot, make sure not to touch it while the device is turned on. Other components of the kit include a holder for the soldering tool and a reservoir. You can use this reservoir to wipe residue during the soldering process. Make sure you follow proper safety procedures while using this kit. Wear either safety goggles or a face shield whenever you solder as a precaution. Occasionally, you may need to unsolder components that are joined together. For example, if removing components from a circuit board, you will first need to melt the original solder. Then you will need to remove any excess solder with the included solder sucker. If you are interested, we also produce and sell a vacuum system for this purpose.
Unit 14. Troubleshooting. Exercise 5, page 31.
General guidelines for equipment repair. BMETs are frequently tasked with fixing broken equipment. If you determine that there is a real problem with the machine, check and see if it's under warranty or has a service contract in place. In these cases, return it to the manufacturer. The manufacturer will replace the broken part or perform the necessary repairs. However, if the problem is serious and the machine is no longer under warranty, consider decommissioning it. In some cases, it is more cost-effective to buy a replacement machine than to repair an old one. Other times, it is necessary to troubleshoot the device. This involves evaluating potential causes of the problem and eliminating them logically and systematically. It is helpful to gather all available evidence of the problem for review. For example, note any error codes the machine displays. Then, attempt to duplicate the problem by recreating the conditions in which the malfunction originally occurred. This can provide helpful information about the problem. During the troubleshooting process, there are some resources you can turn to for help. A service manual might contain helpful information such as flowcharts and code tables. Also, consider contacting the manufacturer's tech support department. Tech support representatives are typically very knowledgeable about the equipment and able to diagnose common problems.
Unit 15. Future of the Industry. Exercise 5, page 33.
Medical Industry Review. The Biomedical Equipment Technician Career Field by Nicole Smithson. For many individuals, a career as a biomedical equipment technician, or BMET, is a great option. In recent years, the field has experienced rapid growth. This is due in part to the increased numbers of aging individuals utilizing the healthcare system. As the number of medical devices in use across the country increases, the demand for expert biomedical equipment technicians also grows. Hospitals and other healthcare facilities rely on BMETs to keep their medical equipment in top working order. BMETs have extensive technological expertise and work in many different types of settings. In addition to working for institutions such as hospitals and nursing facilities, BMETs may also work for original equipment manufacturers, or OEMs. Still other BMETs work for independent service organizations, or ISOs, where they repair a specific company's medical devices. BMETs looking to further advance or expand their responsibilities can work field service engineers, or FSEs. The role of a field service engineer is much more specialized than other jobs within the BMET field. He or she often performs work on site at various institutions within a geographic area. As a specialist, an FSC might also be on call to handle problems with the equipment that might arise.
AVN Pharma Education.